An introduction to the mole. A mole is a unit of amount, just like a dozen is 12, or a pear is 2, or a baker's dozen is 13 of something. It's an extremely large number, though. It's 602 sextillion, or 602 with 21 zeros, or 6.02 times 10 to the 23rd of something. It's a system international unit, just like the kilogram is for mass. The mole is defined against a known standard, and the standard has changed over the years, but now it is carbon-12, the isotope carbon-12. It is the number of atoms in exactly 12 grams of carbon-12, so that's a definition. It is a very important quantity in chemistry. It's a unit that represents the amount of entities or particles of a substance. Chemists deal with extremely small entities like atoms and molecules, so we need a number to make counting them practical, or measuring them practical. 6.02 times 10 to the 23rd is also called Avogadros number in honor of Amedeo Avogadro, and it is the number of particles in 1 mole of a substance. So Avogadro's number has a symbol, big N, subscript big A, and the units are particles per mole. But you have to put in the particle, the type of particle where it says particles, in particles per mole. And that will change depending on the type of substance in the question. So, elements. We can either have monoatomic elements or diatomic elements. Monoatomic elements are all the elements that are not diatomic, and there's only 7 diatomics. So, monoatomic elements will have atoms. So, the particle in Avogadro's number will be atoms. So, you would write that. Na is 6.02 times 10 to the 23rd atoms per mole. It's really important that you don't write particles per mole for every single question that you do. Elements, it's molecules. The smallest whole particle is a molecule. We shorten that to molic for molecule. Then you have your compounds. So you have molecular or ionic. Ionic compounds always contain a metal. So if you're looking at a formula and you're wondering if it's molecular or ionic, remember, ionic contains metals. So molecular. These are covalently bonded compounds. The type of particle is a molecule. So again, the units are molic. So Avogadro's number is 6.02 times 10 to the 23rd molic per mole. Ionic compounds, these are slightly different. The smallest repeating unit is called a formula unit. So Avogadro's number, the particle is formula units, or Fu for short. Haha. Okay, so there is a relationship between Avogadro's number, moles, and the number of particles. So N is the number of particles, small n is the amount in moles, and Na is a constant. It's 6.02 times 10 to the 23rd, and the units on that are particles per mole. Units in moles are mol, and then this one will depend on the substance. For those of you that have difficulty rearranging equations, use the triangle. So basically what you do, if you're looking for moles, you cover up the mole symbol and your mathematical relationship is known. So small n is equal to big N divided by Avogadro's number. If I want to find the number of particles, cover up the number of particles, and my formula becomes big N is equal to small n times Na, moles times Avogadro's number. So the position of the remaining letters tells you the math. So, oops. N is big N divided by Na, and big N is N times Na. Okay, first example. How many molecules of water in there in 2.0 moles of water? What you have to do to get your particles correct is always pay attention to the substance in the question. So here we're dealing with water, which is H2O, which means covalent molecule, which means molecules are the units in Avogadro's number. So how many molecules? So we're looking for big N. We have 2.0 moles, so that's small n, and we always know Avogadro's number because it's constant. So N is moles times Avogadro's number, 2.0 mol times 6.02 times 10 to the 23rd molecules per mole. Now, please be careful when you put 6.02 times 10 to the calculator, times 10 to the 23 in your calculator, because some of you end up being off by a factor of 10 when you do this. So what I want you to do, in your calculator, you will put in 6.02. You're going to look for your EXP or EE or your hat symbol. And this is how you enter times 10 to the 23rd. So you would put in 6.02 and then one of these buttons and then 23, and that should show up then as 6.02 times 10 to the 23, or there'll be 6.02 and then a gap, and then it'll say 23. The gap is times 10. And the 23 is the exponent. So when you do your math, if you have a calculator that does this, you have to be extra careful not to forget the times 10 part. Anyway, back to the question. This ends up being 1.2 times 10 to the 24 molecules. Moles cancel. So in 2 moles of water, we have 1.2 times 10 to the 24 molecules. So in 36 grams of water, there's 1.2 times 10 to the 24 molecules. That's a lot of molecules. Example number 2, how many moles of carbon are there if there are 1.8 times 10 to the 24 molecules of carbon dioxide? So we have a covalent compound, so Avogadro's number, the particles are molecules. We want to know the number of moles or the amount of moles, and we know that there's this number of molecules, so that's N. So we want to find moles. So it's N divided by Na, rearranging our equation. So this is 1.8 times 10 to the 24 molecules divided by 6.02 times 10 to the 23 molecules per mole. So this is 2.99 moles. We have only two significant digits in 1.8 times 10 to the 24, so we can only have two significant digits in our answer, so that becomes 3.0 moles. So there's 3 moles of carbon dioxide if we have 1.8 times 10 to the 24 molecules of carbon dioxide. Example number 3. How many atoms are there in 0.5 moles of iron? Iron is an element, so Avogadro's number, the particles, are atoms. So we know we have 0.5 moles, so that's N. We want to know how many atoms, so that's big N. So when we asked how many, that we're looking for big N. When it's the amount of moles or how many moles, it's small n. So big N is N times Na. So 0.5 moles, 50 moles, so 2 sig figs, times 6.02 times 10 to the 23rd atoms per mole. So 3.01 times 10 to the 23rd atoms. We can only have two significant digits because the 0.50 have 2 sig figs. That first 0 is a placeholder. It doesn't count because the 5 comes after it. So 3.0 times 10 to the 23 atoms of iron in half a mole. So how many atoms of hydrogen? So we're looking for big N. We want it of hydrogen. There's 4 moles, so we know that's N. But our substance is water. And that's a molecule. So Avogadro's number contains molecules. So when we do N, we're not finding the number of atoms of hydrogen, we're finding out how many molecules of water we have. So 4.0 moles times Avogadro's number. So the particle is molecule per mole. So we have 24.08. So 2.408 times 10 to the 24 molecules of H2O. Now, don't round off yet. This is not our final answer because we're looking for atoms of hydrogen. So we're going to take this number and multiply it by the number of hydrogens in one molecule. There's 2 hydrogen atoms for 1 molecule of water. So what happens here is our molecules cancel. So this is called a ratio. This is called a ratio. And we can multiply molecules of water by the number of hydrogen atoms or the number of oxygen atoms, which would be 1, or the number of total atoms, 3. But it has to be set up as a ratio. You want the unit to cancel, which is molecules of water, on the bottom of your ratio so that they cancel. So we have 4.816 times 10 to the 24 hydrogen atoms. We can round this number off because it's our final answer. 2 sig figs in 4.0. So 4.8 times 10 to the 24 hydrogen atoms in 4 moles of water. So that is examples of how to calculate the number of particles, the number of atoms, or the number of molecules or formula units in a certain number of moles of substance. So now work on some practice questions.